Hi everybody, Gary Porter again. I'm just going to review all the circuits that I got going here. This is the PC board, and that's providing 15 volts over to this circuit right in here. And what this does, this discharges the ECM DC energy into this transformer primary right here. This thing in the middle, the core material around this. The primary is 10 henries, believe it or not. That's how big it is because of all the metal around it. And this is my bit arrangement where I've got core out here for providing a path for the back EMF and the secondaries to assist the primary flux. I haven't tested this yet with energy. I've got 70 turns on each of the primaries. I've got to add this meter into this circuit. It's a DC amp meter. This is the capacitor bank right here. There's 18 in series, about 500 farads each. These switches allow me to go from battery or cap for charging, and this is this is a 12-volt battery coming up here. Now I can go to the inverter with this wire here. I've got these two red wires here going to the inverter, and they need to be connected into this amp meter on the top. They give me the DC reading for amps going into the inverter. And this board down here is used. I've got the 3 phases from the motor. There's 1, 2, and then 3 over there. The third one's over there. They all come into here, and they go into these bridge rectifiers, come out of the bridge rectifiers, go over here, go through 3 diodes, and then get combined as DC into this cap through this switch back here. This switch is turned off. This one's turned on to discharge the saved energy in the cap back to wherever I want to route it. So that's the pickup coil path. These things right here, 3 phases from each of the ECMs. There's 4 of these setups all the way around, and they all produce right around between 270 and 315 volts max. So those are all tied in parallel, and that parallel energy comes to this wire right here, and that's going to go to the primary, and then the ground path is provided through the IGBT transistor. This board down here has two timers and an inverter in the schematic, and I'll go through that in a minute. And then it has a comparator which monitors the high voltage on the cap over here. When that reaches a certain level, that switches the output it dumps the output out. The dumping, now the waveform on the scope here, the top trace is free running. That's driving this first switch. So it's constantly filling the cap. No matter what voltage is out there, I can go up to 400 on the cap, so I'm covered there. But then the dumping signal is also free running, but it occurs when the first switch is off. So I've got the one-shot fires based on the edge of this guy, and it goes through 2 inverters, and there's a delay involved so that I can centralize this pulse in the off time, so I don't get a conflict and load the motor down during the pickup coil processing. So I've got the schematics over here, and I don't know how this is going to come out. If you really want schematics, you can email me at captainssbn@yahoo.com, and I'll send a copy to you, whatever. Anyway, this is the first free running pulses out of the NE55 timer. They go through a cap here and fire pin 2 as a trigger on this one shot. He goes through the inverter. There's a delay right here with a cap and a resistor, and then that goes out. And as I showed you a minute ago, this is the waveform here again. And the next page on this thing shows the 3 pickup coils coming in here, going in, and they go through the switch which is free running, and that charges the cap bank up, and then the cap bank goes down through this switch down here to the output. And this right here is the comparator circuit, and how this works is I'm monitoring the high voltage coming in through a resistor and another pot to the comparator to a reference level, DC 5 volts or 4.8 or whatever it is. I adjust this pot, and that determines when this line here gets qualified. This goes to a high level, enabling the dump switch to dump the cap energy out. So this the transistor, the switch driver here, has two things coming into it. Pin 2 is the pulses from the one shot, which is free run. Is the enable, that comes from the comparator. So when I adjust this, I can set this to anywhere from like 80, 70, 100 volts, whatever the pickup coils are, and whatever output I want, and that gives me a qualifying level here to enable the whole beast. So we're getting there. It's one hell of a wiring mess, and so what I did on the new PC board design takes the motor controller with the IRAMs, and that is into this particular switching arrangement here, and that's it. So that's where we are today. Anyway, have a good one.